You gonna make it, Joyce?
Yeah.
Okay. Here we go. 3-2, day 1. You are going to discover a formula to find the arc length for a section of a circle. Okay, ready for your little theorem discovery? Let's say we've got a circle and we know the circumference of this circle is, let's say, 100 inches. So the distance around the whole circle is 100 inches. So I'm going to give you a couple of easy, common sense things you should be able to get in your head, and then from those easy things you're going to come up with a formula. So that same circle, so I'm going to draw it smaller though, so I've got the same exact 100-inch circumference circle. If I take a chunk of it, and I know that the angle is 90 degrees of that chunk, is that enough information for you to figure out this arc length? Yeah. Why 25? How do you know it's a quarter of a circle? And 90 degrees is a quarter of how much? 360. Did everybody follow his logic there? He said that's 90. He knew it was a quarter of a circle because it's 1/4 of a circle, because 90 out of 360 is a quarter. All right. What if we go with 180 degrees? Common sense says, what's that arc length going to be? 50. Because half the circle, 180, is half of 360. 180 out of 360 equals a half. Go one more. How about 60 degrees? How would you get that arc length? Isaac?
16.600 inches.
How'd you get that?
I divided 60 by 360 and multiplied it by 1.
Yeah, so he's finding out what fraction of the circle we're using. That's the common sense part. It's 60 out of 360, which is what fraction of the circle? It's 1/6. So I need 1/6 of the total circumference. So 1/6 of 100, again, I can't do that in my head, but he grabbed a calculator. So 1/6 of 100, what was that obnoxious number you said?
16.67.
So that'd be 2/3? So if this is our process, can you turn this process now into a formula to find arc length if you know the angle measure? So that's what we want next. Hopefully that was enough to do it. So the arc length So essentially in words, what did we do here? What did we do with the angle measure first? Yes.
We created a fraction angle measure divided by 360.
Okay, so we took the fraction of the circle, and we're going to talk about how we get the fraction. Fraction of the circle. And then what do you do with that? Once you know the fraction of the circle,
Multiply it by circumference.
multiply it by circumference. Okay, so in words, that's what we're going to do. And the fraction of the circle, how do we calculate the fraction of the circle? Let's go with a little picture over here so we can see our parts.
Degree measure over 360.
Is it always going to be a degree measure? Could I give that to you in a radian now? Yeah. So it's going to give you an angle there, but that angle could be degrees or radians. And if it's a degree, we'll divide by 360. What if it's a radian?
Divided by
2 pi. So 360 degrees all the way around, and then we learned the other day it's 2 pi all the way around. So it depends on what we're giving, what your bottom number is going to be. So the fraction of the circle, we're going to take the angle measure. We're either going to divide by 360 or 2 pi. Depends on what that top angle measure is. So if it's a degree, we use 360. If it's a radian, we use 2 pi. How do we get circumference? What's the formula for that? Pi times diameter, or 2 pi r. I'm going to stick 2 pi r in here. Reason being, because if I'm in radians over here, the 2 pi will just cancel out nicely. Or if I have pi d, it's not quite as nice of a cancel. So I'm going to choose 2 pi r for this. So there's our formula. Now let's just execute it. So, do I need to break this apart into two separate fractions, or what, are you going to know? Well, we'll find out. So, they use S for arc length. I don't like S, but we're going to go with what the book says. So there's three values. We're going to have an angle measure, a radius, and they use S for arc length. So those are going to be the three things we're working. We're just going to do some basically algebra stuff, where if I give you two of those pieces, you can find the other one. So, let's see what I have for you. Number one. Got a circle. Radius 15.7. An angle measure of 218 degrees, asking you to find the arc length. So we've got our formula there. It's just the fraction of the circle multiplied by the circumference. And the fraction we're working with isn't an intuitive one like I gave you to discover. 218. And because it's a degree, the full circle is 360. We don't have to reduce that. We're going to let the calculator do all the work. And then multiply by 2 pi 15.7. That's strictly calculator work. And if I put some units there, I'll go centimeters. Go ahead and tell me how many centimeters around this arc length is. About, oh, you got it already? What do you got? 59. Everybody else, make sure you can verify this. 7.4 you said?
Yeah.
Okay. Good. We got it. Nothing too tricky there. Okay, moving on. Number 2. A bit smaller. We're going to go for a pi over 5 angle. So when you don't, like I said, we don't have a symbol for radian, but we do have one for degrees. So when you see this number in the angle spot, and there's no degree on it, it's automatically a radian. So I know that's a radian angle measure. We're going to go 12.2 on the radius, and again asking you for the arc length. Nothing changes. It's still fraction times circumference. But to find our fraction, well, the denominator changes. So we've got a pi over 5. And what's the full rotation in radians? 2 pi. Then we multiply it by circumference is still 2 pi r. 2 pi times 12.2. And like I said, the reason I picked 2 pi r instead of pi d is when it's a radian, those just cancel out nicely. You don't have to deal with it. If you did pi d, you'd have to actually divide by the 2 pi. So that's why I chose the 2 pi r one. So now it's just calculator work. Isaac?
7.67.
7.67. So far, so good? Okay. Alright. Change it up a smidge. This time I have an arc length of 6 inches, radius of 4.2 inches, asking you for the angle measure this time. And I want the angle measure in radians. So it's just a plug and chug problem. We just got to work backwards. This time I know the arc length. The final answer is 6, so that's what I start with. The fraction of the circle, I don't know the angle measure, but what do I want in the bottom of that fraction? Because I want an answer in radians. Megan? 2 pi. So by putting 2 pi down here and not 360, we will have it. And then you multiply by circumference, which is 2 pi r. Cancel those 2 pi's off. Oh, why did I put r there? 4.2. Did I lose anybody doing that? Hopefully you put the 4.2 and it didn't follow me. And now it's just divide and you'll have your radian. So about how many radians? It should be over 1. Remember, that's how many radius lengths. It's definitely over 1. 1 point, what do you got, Isaac? 1.4? About 1.4? Or was it exactly 1.4?
1.4.
Just approximate? Okay, just make sure I got that right.
Could we do, put it in just degrees?
You could. You could convert that with our process, but I only asked for it in radians. And when you put the 2 pi under there to start with, that automatically made it a radian answer. As opposed to the next one, I'm going to ask for degrees. .35 is the radius. Arc length is going to be 35.76. I'd like the angle in degrees. So it's still arc length equals fraction times circumference. We never change that pattern. We know the arc length, 35.76, so that's what's going first. It's going in place of S. We need the angle measure, that's what we're trying to find, over. But this time, what do I want in my fraction? Because I want a degree answer. You put 360 down there instead of the 2 pi. And then we times by 2 pi times the radius. So now there's a little bit more involved in the calculator and the algebra, but it's still just an algebra problem. you can do several things here. You could multiply by 360, then divide by this whole chunk. Go ahead, try something on your calculator, see what you get. Oh, I thought you were coming to talk. All right, that's fine. Okay, I want you to crank through something. See if you can algebraically get that on your own. See if your techniques work. You gotta work backwards, solve for theta. Go. There's gonna be different ways to get there. Just stay on the legal roads of algebra. No off-road stuff. What'd you get, Isabel?
278.76 degrees.
I'm in agreement, so we'll wait for people to get there. I have about 279 I rounded to, but yeah. Anybody not able to get to around 279? Okay, we'll let you tell us what you did. We'll see where you went off road. All right, what'd you do first, Megan?
So I wasn't going to do, I was going to flip it, like the 2 pi times 7.35, flip it and have it 1 over 2 pi times 7.3.
Is that what you want to do on both sides of the equation?
Yeah, that's what it's doing.
Okay, that works. That's legal.
So flip it and divide 35 times 7.35 by 2 pi.
That's legal. And then what?
And then choose to divide it.
Yes, you would. So, your process was great, your calculator skills are bad. So now we're down to good knowledge, bad execute. So, tell me how you typed in your, flip that over, and then you divided it over here. Tell me exactly what you typed in. You don't know. You said it great. If you want to do it correctly, like you said, you said you would divide by this whole chunk over here, right? The 2 pi 7.35. Watch me. 35.76 divided by. If I want to divide by that whole chunk, I got to put it in parentheses. 2 pi times 7.35. That's the quickest way for me to do it. And then you said times that by 360. You had a great plan. Anybody else need help with their algebra? Anybody else go off-road? That's not the only way to do it, just so you know. Can I move on? Okay, moving on then. Number 5. This problem involves towns on the same longitude line on our Earth. Longitudes run north and south. Okay? We can use this formula to find the distance between towns as long as they're on the same longitude line, because the cross-section of the Earth is approximately circular. So, this is problem, towns on the same longitude line. Oops. Longitude line. Okay. So we're going to find the distance between Farmersville California has a latitude of 36 degrees north, but it's on the same longitude line as Penticton, British Columbia, which has a latitude of 49 degrees north. Find the distance between them. distance between, knowing that the radius of the Earth that we're going to use to 2 sig figs, 6,400 kilometers. That is a value you are going to have to remember. They don't give you that in every problem. The Earth doesn't change. That radius is what we're going to use. So, if we take this cross-section, I don't know what longitude line they're on, but they're on the same longitude line. If you take a cross-section of the Earth, you're going to see a circle. These latitude lines, like the rungs on a ladder run east and west, so our equator is the 0-degree latitude. Are we in agreement there? Now we've got this California is 36 degrees north of that equator. So that means if I go up 36 degrees, that's going to be that Penticon, British Columbia. That's a 36 in there. Because these numbers are how far north and south of the equator. Now this Penticon, British Columbia is 49 degrees north of the equator. So we start at the equator and go up 49 degrees. And we will be in Penticon, British Columbia. The question is, oh, I wrote this wrong. Farmersville, my bad. Farmersville, F. Why don't you people tell me I make mistakes? Makes it so much easier to understand when I don't make mistakes. So speak to me. All right, the question is, how far apart are the towns? Well, because the Earth is circular like that, it's just the arc length between them. So, in order for me to find arc length, I need to know the radius and the angle measure. I got the radius, 6,400. What's the angle measure of this piece of pie?
13 degrees.
How many?
13.
13. Where'd 13 come from?
49 minus 36.
Yeah, 49 minus 36. And now it's just the fraction of the circle times by the circumference. So our fraction, since I've got a 13-degree pie piece, I divide by 360 times by the circumference of the Earth, which is 2 pi r. And these will be 2 sig fig answers in the book every time on these. And how far apart are they? About 1,500 kilometers. Rounding to 2 sig figs. Questions on that one? And one left for you. Okay. Still using the Earth here. What are we on? Example 6. All right, Madison, South Dakota. South Dakota. And Dallas, Texas are on the same longitude line. They are 1,200 kilometers apart. Dallas has a latitude of 33 degrees north of the equator. I'm going to ask you to find the latitude of Madison. Picture's definitely gonna help you out on this one. Are you ready? So, give yourself the Earth. I would always give myself an equator, because the latitudes are measured from the equator. There's our 0. Okay, we've got Madison, South Dakota, and Dallas, Texas, so you gotta know a little geography. We've got Dallas at 33 degrees north, so we'll swing up 33 degrees. Dallas. Madison, South Dakota. North of Dallas or south of Dallas? So we gotta go farther. So we're looking for how far north of the equator is this town? So to end the problem, we need to know how far north of the equator. We don't know what it is, but we know this is 1200 in here. We know the radius of the Earth is 6400. So if I know those two things, I'm going to be able to find the angle between the two towns, which is not the latitude, but it's going to help me get to the latitude. So we are going to solve for this theta right in here. That's what we'll find. Then you turn that into a latitude after, which should not be very hard. Are you ready? So we plug and chug. Our F value is 1200. Oops, 1200. The angle we don't know, but I do want it in degrees, so I'll divide it by 360 to get the fraction of the Earth that we're working with there. Times by circumference of the Earth, 2 pi 6400. Okay, work your algebra backwards again. There's my calculator work. I did it in 2 lines. I did the times by 360 first, and then I divided by that whole chunk. Show as much work there as you want, because the algebra from getting from here to the answer is only worth 1 point anyway, so you can either get there or you can't. Okay, I'm going to say 11 degrees, because we're only 2 sig figs in our answer anyway. So, everybody else get 11 degrees? All right, so if that's 11 degrees, what is the latitude for Madison, South Dakota? 44 degrees. Latitude is 44 degrees north. If the book gives you latitude south, what does that mean you're going to do? Just go below the equator that many degrees. Okay, that's all I have.